I'm also going to go over, like with most problems, I'll go over how you should address the problem. And then a lot of times I'll also go over, if you didn't know that, but you would know a little bit, this is where you should have started or at least gotten to. So I'll talk about problems in a bunch of different ways. Some problems concern me more than others, that they're in this list of top problems missed, but for different reasons. So this, number 30, is the most missed problem. And it is not that hard of a problem, but I'm not concerned with this one. Because I think the wording of this problem is confusing and doesn't get you to where you need to be, but once you get to where you need to be, then this conceptually is a very easy problem. Alright, so delivery service places package into large containers for flying across country. Suppose they always transport 2 on each flight. The 2 containers are chosen.
Should we write like contextual stuff, or should it just be generalized for this?
It's absolutely up to you. I'm gonna write a lot of both on the board, and it's totally up to you. Yeah.
We get to take our test.
Yeah, so I'm not gonna take your test back at all now. Like I have everything I need. You can write on your test, and I don't mind if you do, but remember when I'm going through and checking your stuff, like I need to do it's on notebook paper. It's like marking all over this is fine. Just make sure you also write on notebook paper. So 2 containers are chosen, so their combined weight is close to, but does not exceed a specified weight limit. So there's something that they want to get close to but not go over. A random sample of flights from these containers is taken. Might be important. And the weight of each of the 2 containers is reported. So the weights of the 2 containers are something. Well, I'm going to look at answer choices and give myself a little bit of direction here. What are all these generally talking about? So I need to think about correlation. So I'm going to write some side note stuff about correlation first. What is correlation? Symbol. Alright. What are the possible values of R? So -1 to 1, which is 0 to 1, positive, negative. And then it generally follows the scale from -1 to 1 to where numbers that are around here are considered what? No correlation, or the closer to the middle, I guess, should say weak. So 0 would be none. Here would be weak. Something out here would be considered what? And then all of these are obviously negative. All of these are positive. So R tells us strength and direction. So is this question asking us about strength or direction? Direction. So let's think about what direction actually means. So let's say we have a positive R. Positive R would be as one thing increases what? The other one also increases. A negative R would mean instead what? As A increases, B decreases. So they change the same or they change opposite. Height and weight, positive or negative? Positive. As you get taller, you're going to weigh more. You could do something really obvious and do money spent and money left would be negative. As you spend more money, you have less left. Alright, so this almost gets us to where the problem gets easy, but we're still not there yet. This is just kind of background stuff, and then all of a sudden it'll click with why this problem is supposed to be easy. I'm gonna clear everything I have written just to have more room. Alright, so we measured two things, the two containers. So I have container 1 and container 2. What do I know about container 1 and container 2?
The combined weight.
Alright, so let's come up with something easy and say we want the weight limit to be like 100.
Mhm.
So if container 1 is I want to write combined weight of 100, but I don't really have much room. So if you're doing notes, combined to equal 100. Alright, so I'm just going to write down some numbers for what container 1 could be. Container 1 could be 30, 50, 60. If container 1 is 30, how big can container 2 be?
70,
Container 1 is 50, how big can container 2 be?
50,
And then my last one. So as my container 1 increases, what happens to container 2? And I think it was hard in the wording to understand that that's what the problem was asking. But once you thought about it that way, then this is an easy problem. Obviously, as the bigger my container 1 is, the smaller my container 2 has to be, which means the answer is what? Oh, and that's another thing. I purposely did not tell you which problems you got right or wrong, or how many you got right or wrong. I think you pay attention more, and a lot of times people, if they got it right, they're not going to listen to that problem. But I go over a lot more than just the problem, so I don't want to do it that way. And another thing that I should have said last class, I didn't think about it this way. I think I had some people leaving really deflated because we went over 6 problems, but I went over the most missed 6 problems. So if you leave this room today not getting a single question right, that's probably fine. Like we're going over the hardest ones first. And I didn't think to tell that to my last class before somebody made a comment. So be okay if you don't do very well once we go through that.
I have a question.
Yes.
How did you know that we were trying to determine like which direction we're going with this?
Okay, because of my answer choices here being, okay, I'm in the middle, I'm at the end, or this, instead of saying strongly. So I use my answer choices to go backwards.
Did you choose 100 or 100?
Yeah, I could have used whatever I wanted there.
Do you want us to put the correct answers on this building?
Like it's yours now for whatever you want to review, so. And like I said, if this sparks any kind of question with material, this is just a structure, so just stop me whenever. Alright, so going to number 34. I think I'm going to start this problem with an idea instead of how to answer it. So researchers conducted a survey using a simple random sample of 50 registered voters to create a confidence interval on a test to estimate the proportions of registered voters favoring the election of a certain candidate for mayor. So assume the sample proportion does not change. That's actually extremely, extremely important, but most of you probably won't pay attention to or think about that. Which of the following best describes the anticipated effect on the width if the survey were to if they were to survey 200 as opposed to 50? So I'm changing what? I'm changing my N the question wants to know what's gonna happen to my width. So you definitely need to get to the point where you can say, okay, I know what the question is asking. Alright, so I'm gonna start this problem as I am so confused and I have no idea where to start. How is my width, how is my sample size changing?
It's increasing.
Which is my old sample size was what? My new sample size is, so my sample size is what? Increasing. This is the concept you have to know. As sample size increases, or n increases, you need to know what happens. So in general, the confidence interval or the, oh, here's, what else can I call it? What's this problem asking about? Width. What's another general way? You just sit anywhere. And you need a white sheet. Yeah, just write white sheet off of one of them.
But I'll put it anywhere you want to. Where are the elections?
There's one on that middle desk. They were supposed to be on all desks, but I'm moving around.
Oh, okay.
And I don't care what it says. Okay, as the sample size increases, the width of the confidence interval, what's my generic word for that? Another S word? Which is standard deviation.
Hey, nice.
So as your sample size increases, your spread does what? Decreases. You have to know that. In the first 6 questions, that comes, or first 8 or so questions, that comes up twice. So let's say that's all I can come to right now, and I have no idea where to go from there. Well, here, the new interval is a fourth, the new interval is a half, the new interval is the same, new interval is twice, new interval is 4 times. I am now down to 2 answer choices just because I know this, and I've not done anything yet. And that part, I need you to know how to at least get there. Now from there, I'm going to get into actually solving it. Let's write, so this is not necessary, you don't have to write this part, but I want to talk about it. What is our equation for confidence interval for one proportion?
In terms of money.
P hat plus or minus?
V square root of P hat plus P hat minus 1 grand, or 1 minus 2.
On your orange sheet, this equation is not on there, but one that is close is on there. Oh, it doesn't give the actual equation, but it gives you like the sample proportion being square root of P, 1 minus P over N.
Oh, yeah.
So like you can use some of those help if you get stuck. So if I am changing sample size out of this entire question, or out of this entire equation, what's the only part I want to change? I'm just changing this part right here. So I just want to look at something under the square root on the bottom of a fraction. So in the equation, this was in the square root, the bottom of the fraction. My new one is in the square root at the bottom of the fraction. This part up here is saying, assuming the proportion does not change. So whatever was here in the first one is here in the second one. Now I can find numbers and plug them in, but if they're not going to change, do I care what they are? So let's just call it 1 to make it easier on us. So now type in, what is square root of 1 over 50? The square root of 1 over 50 gives us what? And what is the square root of 1 over 200? So is that half or is that a fourth? Now, there is a way to answer this problem that some of you did during the chapter that you probably forgot about. When I go from 50 to 200, how did my sample size change? Multiply by 4. Which means, how does my standard deviation change?
It doesn't.
Take these and then orange and then white and then go sit in the hall and start working. If you multiply the sample size by A, that means we dealt with this before. So if you made it 9 times bigger, you reduce your standard deviation by a third. And in that chapter, a lot more of you went this direction because that's all we were dealing with was that chapter. On the AP exam, I probably wouldn't expect you to memorize this. I would expect you to be able to get there with this. Like this is a lot more likely than that. But worst case scenario, you need to be with me at the beginning. Because like you can see that that's twice as much. Like I can literally type in this divided by that, and I just went, yes, I didn't make that connection. Oh, I didn't talk about one other thing in the beginning of your class. Maybe I was missing something. I tend to overlook things that I think don't need to be discussed. But maybe I should. You get the Z table, the T table, the equation sheet, all that on your exam. But there is no sheet on the exam that is green. There is no sheet on the exam that is purple. There's no sheet on the exam that is orange. I do them in my colors so that we can know which one it is, and I can tell which one you have out. But I have had someone who got to the AP exam before, looked through it, said, there's no green sheet, I don't know what to do, and never found it and never used it. So I need you to know things that I don't think I need to say. They're not those colors on the AP exam. And I'll go through this a little bit more, but it's just like a typical standardized test where like all the equations are in the back, I think, or the front. This was last year's. They had to modify it last year. It looks more like your orange sheet. But they do like all the equations first, and then they go, here's your Z table. I printed your Z table as 2 of them on one sheet, but theirs is the left side is the negatives are on the front and the positives are on the other side. So that's the left half of Z, the right half of Z. There is T, and there is technically chi-squared. I never even showed you this chart because I don't think there's any reason to do it because our calculator does everything. Technically, you could have used this and gotten the same thing. But so this is the way that it looks in your exam. They're not in color. Just making sure we address that. Next one is number 21. This problem, I'm not surprised at all that it is one of our most missed problems. But some of the things that you didn't know at this point within this problem probably concern me a little bit. Just because you need to know these, but us covering them now is fine. Like, it's been a while since you've done this. Okay. An experiment has 3 mutually exclusive outcomes. What does it mean to be mutually exclusive? So if I do this, do I draw circles that overlap or don't? I said just so we get our concept, it's going to be something like this. And it gives you numbers for them. I can write those right now. I'm going to start with 2. Probability of A and B. So if 2 events are mutually exclusive, can you be both at the same time? No. So if I can't be A and B at the same time, then my probability of A and B is what? And that's what that one means.
That's the one that I said. Wait, what did you just say there?
If they're mutually exclusive, they can't happen at the same time. If they can't happen at the same time, the probability of A and B is 0. Now this second one, and I want to show you this on your equation sheet so that we're looking at the same thing. Look on the side of your equation sheet that's not like boxes and find something that looks at least similar to this. What does it start with? And then so the U thing, just so as a reminder, means or. And so then it says probability of A plus probability of B, but then what?
Minus.
Now this equation is for what kind of events? And you should be able to see the difference because of what we just said here. So if they are mutually exclusive, what of this does not apply? Because it's what?
Zero.
So this part is all that we need if they are mutually exclusive. So is 3 correct? Because the two events are mutually exclusive. So to get A or B, I just add, or probably B or C, I just add B plus C. So 2 and 3 are both correct. Again, if you have questions, stop me as I'm going, I don't mind. So 1 is where I would not be surprised where most of the issues are, especially since I just threw a test on you and didn't say like, hey, go study for it or anything. So if A and C are independent, how do I check to see if they are?
A and C over B and C.
You're using that, but I don't want to say anything. So what you're saying is right, but I don't want to get that context.
Probability that C happens after A.
Given, yeah, which is under the assumption that. So probability that A happens given C.
Wait, look at the, no, she's saying something that
So this is the equation of what you're seeing. That's what I'll say. I didn't want to answer that. This would be equal to what if they are independent? That's just the equation part. So if I am independent, I don't care what you do, I'm going to be the same. Is it the same? Probability of me doing something is going to be the same as probability of me doing something given that you did something else. I don't care what you did, I'm doing the same thing. So now on, this is a concept that you'll need. This is one that is important that you will see. Alright, so now let's go back to it and think it applied to this problem. Probability of A given C. So given that I'm in this circle, what's the probability that I'm at A?
Zero.
What is the probability of A?
12.
Not 0. So they're not independent. So our answer ends up being B.
Can you do an example of the given probability was they are,
Yes. Yeah. Yeah. And I'm gonna do it in a way that might not be like a write-out thing, but I think it'll answer your question, then if not, then I'll go from there. Alright, so she asked about, she wants to see a given thing kind of written out. I'm gonna do an example here. Alright, what is dang it. Not thinking through this. I know I need to switch. Okay, yeah. What is the probability that it is red, given that it's a circle? So how many of them are a circle? And how many of them are red? Alright, so I want to know if this is the same as this. Well, how many of these are red? Out of how many? Which is what? So in this case, circle and red are independent. Does that answer what you were asking me to do? And if not, I'll do more, but that was good.
So like you do, like if it's A given B, you do A divided by
A out of the total of B, yes. Alright, number 16. This one does not require much conversation. You either know this or you don't. I'm not surprised that a lot of people miss this, but once I tell you this, you should know not to do this anymore. Alright, so how do I find, like, conceptually, how do I find me? Add them all up and divide by how many there are. So if I've got somebody who has a class full right here, they just donated money, I can find that me because they can add up their money and divide by how many there are. I got a class full over here, they donated money, I can add them up, divide by how many there are, and find separate averages, right? Can I put their money together and find out the overall average of those classes? Add the money and then divide it by all the people, right? And I can do that if all that I told you was, this is how many were in this class, and this is what their mean was, this is how many is in this class, this is what their mean is. That's all you need to do that equation backwards. So, of those answer choices, which one of them would find me the mean?
Okay, and then so,
Yes.
I
Alright, so which one of those is the equation of finding the combined mean? C. you did the other half, right? Okay, all of that, and then you'll have to go backwards.
I'm guessing it's.
So start with us, and then you'll have to do like, you'll make up the ones that we've already done. But if they're out of order, just like write me a note or something. Alright, so this problem instead asks us about what? How do you find the median?
You count up all of the numbers, you find the one in the center.
You find the one that's in the middle. If all I tell you is what the middle was, can I combine two classes and you tell me what the new middle is? No, because the way to think about it here is, I know that this one's bigger, but I have no idea if there were any numbers in this set between here and here, or the same thing opposite. So like, I don't know if that middle, I have no idea to know where it's gonna be. So you cannot combine to find median just from the original median.
Wait, can you say that one more time?
It's just the way, like, it makes sense of how you undo it and put it together, like for me, because of what the equation is. When you're just saying middle and no other information, I can't just put middle and middle together and find new middle. Like conceptually thinking through how to do mean, it makes sense. Well, I just add them all together to have the totals, divide by the totals. But median, I would need more than that. So I
So
can't.
what does 47 measurements have to do with anything? Is that this, the 30 off?
No, so it would.
If you were doing with me, which is what?
And a lot of times you'll see a question just like this one, and it actually does ask for mean. And so you do this. I've seen some questions that ask for both, and it'll be like this one, but median could be down, like a combined. Alright, so this is the fifth problem.
So, if we wrote something for that, can we just say like, could not be determined with the.
Combine, can't find combined medians without all the data. Alright, so number 12. This one, I'm not at all surprised where it is. Both of them are normal, but all of our answers say normal, so I'm probably not even gonna look at that. So I just need to figure out what's the mean and what's standard deviation. So I've got X, and I've got Y. I've got means and I've got standard deviations. My mean of X is 10 with standard deviation of 3. My mean of Y is 9 with standard deviation of 4. And we are putting them together this way. So when I find the mu, the mean of Y minus X, means pretty much all across the board for everything in our class work just how you would think they would. So how do I find the mean of Y minus X? Just subtract them. I take the mean of Y minus the mean of X. Mean of Y was what? Mean of X was? So that knocks out 2 answer choices. Now, here is where the issue would be, and this is something that, again, you didn't study before you did this or look up or anything. So when you are combining random variables, to find standard deviation, there are 2 rules that we have to follow. You said one of the rules is what? Combine as variances. And what does it mean to be a variance versus standard deviation? You just do what with it? Square it. What was our other rule? Always add. If I'm 5 feet away and I'm 7 feet away, I'm not all of a sudden going to be 2 feet away. So you always add and you combine and state a variance. So when I am doing sigma of y minus x, I want my y as a variance. So sigma of y squared. I'm adding in between, even though the problem is subtract. Sigma of x squared. But now I'm in variances, so how do I go back from variances to standard deviation? So I've got 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9. Those add to give you square root of 25, which is 5. So we've got stratified. What is another one? What's another one? And our last one? With these two, we start out with grouping. But the way that we group is different. Just to review, because it says it up in the words, the groups are called strata if it's stratified. The groups are called clusters if it's cluster sampling. But how do we group them if it's stratified?
Based on a similar.
Based on a similar characteristic. So they are similar within the group. So that would be something like just freshmen, then sophomores, then just juniors, then just seniors. Cluster instead should do what? And so they should generally reflect what? We hope that they generally reflect
The whole
the whole population. That could be something like, and I know this one's not a great example, but like second lunch would be a way I could cluster, because in that one lunch, I should get all 4 of the different grade levels. Now, it's a little funny because seniors leave early and they get the seniors' third lunch, but that kind of gets the idea. So here, I want the groups to be separated, and I want each group to be similar within itself. Here, I want the groups initially to reflect the population. So the next thing is who I select. So who do I select with stratify? Certain proportion from each group. So I say some from every. With cluster, who do I select?
One of several clusters.
Entire clusters. If I'm picking lunches, I'm probably just gonna pick one lunch. Like I would put 1, 2, and 3 in a hat, and then pull out a number, and then that's the lunch I would select. Just because I saw some looks earlier. What we're hoping for is something like this in each of our samples that we end up with, where these should look the same. But here, it happened because I picked from groups that already had all the different colors. Here, I specifically said, okay, I want to pick some green, then I want to pick some blue, then I want to pick some orange, then I want to pick some red, to make sure that this is what my group looks like in the end. We should be getting the same result. It's really how we get there that's different. Systematic. People forget the first step. They overlook the first step. What's the very first thing I have to do
Randomly choose.
before that? Okay, so like, what most people would say is first step is I need to randomly choose what? Yeah, Your first number and where to start. Okay, so I've got a room full of you. What do you mean, where do I start?
Oh, you have to assign each individual a number?
So I have to put them in
Order.
somehow. And then, that's the part that people just overlook. So then we have a random start. And then we have a random what? Random selection. Some people think of it as interval, and some people would rather write it as like the int. So this is the one, it makes sense, it's a very systematic way about this process. But now when I order them, do I want the order to have anything to do with what I'm asking about? No. So if I'm asking GPA, I might order you by your height, because your height shouldn't have anything to do with the GPA. And then E is the definition of simple random sample. And just to bring this up again, because I had a question about this last class, they said, why is E not stratified? Because if we're thinking about it like, I am picking 4 people to represent our school, and I'm going to do a stratified, which means I want 1 freshman, 1 sophomore, 1 junior, 1 senior. Is it possible for you and your senior best friend to be chosen in my sample of 4? No, and that's why E is not correct. Is because every possible group that I take of 4 people does not have the same chance of being selected. Any questions with stuff off that one? It's been a while since we've talked about sampling. All right, now this problem, if you wanted to work it out correctly, like from the beginning to end, all the steps of it, it's tedious and there's a lot to it. Not like a whole lot, but it's tedious. But you can get to the answer without ever actually doing this problem. But what most people do not understand is what in the world this problem is asking or talking about. Alright, so a game of chance is played in which X, the number of points scored in each game, has a distribution shown above. So let's talk about that. I'm playing this game once. What can happen in that one game? I can get 0 points, 1 point, or 2 points. Okay, so I made association with what the picture's even talking about. 2 is where people just either get lost or confused or overlook the detail. Which of the following is true for the sampling distribution of the sum of the scores when the game is played twice? So that's what I'm concerned with, is when I play twice, how many points did I get and what's my probability? Everybody go with that part, what the question's asking now? All right, so let's start here. And let's just think about how many points I can get. Can I get 0 points? Yes. Okay, they all have 0, we're good. I usually go through these answers and look to start. Okay, they all have 0, so I'm not even going to think about that. Some of them don't have 1. Could I play this game twice and get 1 point?
Yes.
Yes. So, no. Can I play this game? So now I have to decide here. Can I play this game twice and get 4 points?
Yes.
Yes. So I am automatically down to 2 choices. This one is telling me exactly what the probability of each one of them is. This one is telling me binomial mean of 2. Do you think the mean is going to be 2 out of these? And most people aren't going to look at that part, but that doesn't seem unreasonable. What does this mean?
There's only 2 outcomes.
Yes or no?
No.
There's 3 outcomes. So is this binomial?
No.
No, I never had to solve this problem with answer C. Now I am going to actually go through and solve the problem. And I think those of you who are still like, I am so lost, will understand what I'm doing once I actually solve the whole problem out. So now I am using this, I just can't have it both on the screen at the same time. The probability of me getting 0 points is 0.3, probability of me getting 1 point is 0.4, probability of me getting 2 points is 0.3. So I'm using that in just a second. I'm trying to not switch to a different slide so that y'all can always be looking up here if you're confused, like if you want to double check and make sure you're on the right number. I'm trying to keep that page number the same. So I played the game once. How many points could I have gotten?
0 and 2.
What's the probability that I got 0 points? Probability I got 1 point?
0.4.
Probability I got 2 points?
Wait, why does it go to 0.4 again?
If the chart, this little graph thing, just shows you that.
Oh, okay. Oh, yeah.
I play again. If I got 0 points, now how many points can I get? You see what I'm saying? I asked that down. I could get here, and then the second time get 0, 1, or 2. I could play this time, and then the second time get 0, 1, or 2. Everybody with me?
Mm-hmm.
My same probabilities, 0.3, 0.4, 0.3 for all those. And I'm going to do this part first because I think I did this too quick in my other class. Let's talk about my probabilities for each. What is the probability that I go down this first path? 0.3 times 0.3, which is 0.09. What is the probability that I go down the second path? And most of these are really easy because they're all but one of them are either 0.9 or 0.12. So 0.3 times 0.3 is 0.09. 0.4 times 0.3 is 0.12. We got one that's 0.4 times 0.4, which is 0.16. 0.12, 0.09, 0.12, 0.09. Everybody good with there? I just multiplied down for each one.
Mm-hmm.
All right, so now let's look at y. I guess I should have written y there instead of x. Which is my sum. If I took this first path, how many points did I get? If I took the second path, how many points did I get? Then 2, what would my next path be?
1.
So I'm just adding the numbers going down. Everybody with me? So my options, I'm going to condense this same chart. My options for y were 0, 1, 2, 3, or 4. What is the probability that I get 0? 0.09. There was only one choice. I didn't have to deal with anything else. Now, what do I need to do to find my probability of getting 1 point?
Average of both numbers.
I would take this one plus this one, which gives me,
0.24.
I'm going to start from the other end, just make it easier. There's only one that's 0.04, which is 0.09. There's 2 that are 0.03, which is 0.12, 0.12. And then there are 3 paths with 2 points, 0.9, 0.09, 0.16, which is 0.34. This is your final answer in a chart instead of in words. And had you actually worked out the problem correctly, this is the way you would have done it, which is a very tedious problem. If you look at the problem and think through it, we could have gotten an answer without actually doing that. Questions about that problem? They like to throw in a problem like that. So just remember, if you're doing a distribution more than once, or you're taking the sum of a distribution, you're kind of thinking about it like a tree diagram, whether you actually draw it out or not. wouldn't have thought to do this, but what kind of distribution do you think that is? Fairly normal, right? What happens when I take two fairly normal distributions and put them together? I get another normal distribution, which is what we got here. All right. I would probably consider this to be one of the harder problems on this test because now there's not much math at all involved. The math is extremely easy, but you've got to make connections between things here. And I'm going to talk about a whole bunch of different things before I pull any of it together. This is a T statistic. What do I usually call that instead of a T statistic? A test statistic. Some people in the chapter 12 test got thrown off by the fact that it was called T statistic, not test statistic. It's used to conduct a test of the null hypothesis where mu equals 0 against mu does not equal 0. Well, what does this mean? Two-tailed. The p-value, okay, I've got my p-value. The two-sided confidence interval, well, that helps because we're dealing with two-sided in both, is to be constructed of the following, which is the largest level of confidence for which the confidence interval will not contain 0. Let's just think about this last part. If I draw a confidence interval and I get something that is here, what is my result as far as like a test? If you said I was going to make between $20 and $40 and I made $25, I'm not going to say you lied. If you said that I'm going to make between $20 and $40 and all of a sudden I make $15, I just thought about that. I wish I would have done that earlier. And I'm going to put here or here you would reject. Doesn't matter which end it's on. So we understand that in a confidence interval, what it means to reject or fail to reject, correct? These blue lines, if I were doing a test, the blue line would represent what number?
0.
Because it is the number from my hypothesis. I'm figuring out if 0 is in one of those three places. Now, p-value, so let's switch gears completely and just decide about a test. In a test, if the p-value is what, we reject. So this one associates with this picture, right? So now let's go back to the problem. Of the following, which is the largest confidence interval of which the confidence interval will not contain 0. So left or right one here, which is the one that will not contain 0.
Right.
The right one. So that means reject. What does reject mean? Reject means that our p-value is less than alpha. Everybody with me there? Okay. If our confidence interval is 90, what is alpha?
It's the 1. It's 0.1.
Because how much is left? What is our alpha here? This is the part that I think most of you would have the issue with, is just this piece right here. We have one p-value, which was what?
0.056. Is it C?
And we want to know the one that will not contain 0, which means reject. So, is it less than, do we reject here?
Yeah.
Do Do we reject here?
Yeah. No.
So these two would reject. So which of these confidence intervals is the largest that would reject? That is a difficult problem.
I got it right. I don't understand. I don't know. We all suck.
You understand those going to get rejected? So this part says, which is the largest one? So those two, which is bigger? One minus. So like, this is what's between, so this is not between. So you're doing like 100 minus that.
So I did it. If it was like you're a 5 and 95%.
Alright, questions on this one? Like I said, that's a very easy answer, but getting there is a lot of pieces, and I think that one is difficult. This one, however, I'm worried about. If someone said, pick one problem from this AP practice exam that represents like the core of our class, I would probably pick this problem. And it is order number 9 in our problems that were missed the most. Alright, let X represent a random variable whose distribution is normal. What is really important? What do I know about normal? So I know my 68, 95, 99%, 99.7%, and what else? What does it look like? Bell shape. And I can use, I'll give that one second. With a mean of 100, standard deviation of 10. So I'm going to draw this a bunch of times. So 100, which means this is 110, 120, 90, 80, and I can keep going past that from this problem. I just don't need to. And this problem is saying which is equivalent to starting here and shading that way. Most of you, I would not expect to draw out all that I'm getting ready to do, but if I do it this way, then I should be able to catch everybody. All right, so I'm going to draw this 5 times really quick for each of my different distributions. Now, I'm not going to write in the numbers. I'm just going to show them the same thing. So I'm going to start at the middle and then 2 each way. Keep sliding where I'm writing. So A says starting at 115, I guess I should write 100 as my reference. It's easier to tell. Starting at 115, shading which direction? The left, it says less than. B says starting at 115, shading which way? Is there anything different about A and B? As far as our class, no, because a line itself has no area, so those are the same. C, I'm starting at 85, that's here, and shading which direction? D, I'm starting at 85, going to 115, and I'm shading everything in between. E says starting at 85 and going less than that, but I want everything that's not that. It's actually saying starting here and going that way. So which is the same as this one? Which is the same area as that one? I should be able to get everybody as far as idea wise here, but I don't think all of you would draw that picture out. So normal means curve. What else does normal mean? What do we always associate with normal?
Deviation.
What else? Paper.
The
The z-score table. So can I convert these to z's? So these are easy numbers that it gives you. A lot of times it does this. So 1, 10, and 10. This is 15 above. Well, 15 divided by 10 gives me what? 1.5. So this is z is less than 1.5. This is the probability that z is less than or equal to 1.5. This is the probability that z is less than what? This is the probability that z is between negative 1.5 and 1.5. This is the probability that it ends up being that z is greater than negative 1.5. This answer is saying, so being greater than 1.5 is the same as what?
less than
And so some of you would go straight to this process thinking wise as opposed to drawing. It's the same idea. You're just either drawing it out or using these scores written down. But that is something that concerns me. Because that's a very basic to what we do problem. All right, number 13. The graphs of the distributions 1 and 2 of the sample mean of the same random variable, which just means we're sampling from the same thing, of 2 different sizes are shown. So the only thing we are changing is what? Sample size. Finish that.
That looks like all.
As our n increases, spread decreases, which is the exact same concept we got out of one of the other problems yesterday in our first 10. So, is distribution 1 a smaller spread or bigger spread? So this is a smaller spread. This is a bigger spread. Which means this is a what kind of n? Bigger n, and this one is a smaller n. So A, the sample size of 1 is less than, is that true or false? False, so that's the bigger one. The sample size of 1 is greater than the sample size of 2.
Let's go.
This one says they're equal, they're obviously not. This one says it doesn't affect it, not true at all. This one it says we can't compare them, which is also not true. Now, beyond our class, the big important thing here is that it's of the same random variable. Like that's actually really important, but as far as our class, they're not gonna try to trick you with that part of it. But yes, we would have to be sampling from the same thing to be able to know that it would change that way. What happens, so going back up here, as n increases, what happens to our mean? What happens to our center? What happened to our center here?
It doesn't change.
Nothing. It does not change. Our center is our center regardless. Number 10. This one is an easy problem. There's a tiny piece of it that makes it tricky. Alright, distribution of the parameters of variety of oranges, approximately normal. You need to be the point where you always circle or underline if you see the word normal. Standard deviation of 0.03. How does the diameter of the orange at the 67th percentile compare with the mean diameter? Approximately normal. So I'm going to draw it. Finish that. Percentile always means shade left. The people who did less than you. People who you did better than. So backing up here, if this is my middle, what percentile is the middle? 50th, because half of it's that way. So if we have a number that is above 50, where is my line for that percentile? Has to be because it's more than 50. So all of this is 0.6700. Briefly glance at your answers when you're trying to solve a problem. I've got 5 answer choices and I'm not done. Where is this line in relation to the mean? So we know it is not below, so we can go ahead and eliminate 2 answer choices. And I'm going to show you the thought process behind this one, but I'll show you how to get to the answer a different way too. This is my area. Can I find this? Yes, so how do I do that? Where do you look for this? You don't have to. So look at the table. Is that number going to be at our table? So you're looking in the middle part for it. So if you look in the middle part of your green table, which is the table on your desk that's not green, it's not going to be green. So that's just using the chart. It's been a while since we've done that. This is my what value? Z. So my equation for Z, my really general equation is Z equals what? Of some form. Do I know my Z's?
Yeah.
What else do I know? Standard deviation, which is 0.3. I can get rid of this, multiply it both sides. What is 0.3 times 0.44? This is the only part of the problem that's tricky. How does the diameter compare with the mean? What does that say? How far am I from the mean? So how does it compare to the mean?
It's that far above.
That far above.
You get it.
Now, I think that part loses people. So instead, the way I would think about it is, let's come back to what I drew up here. So this is a Z value. Let's think about it like this. So this is 0, this is 1, this is 2. Where does that fall? Somewhere between what? This falls between 0 and 1, right? You with me on that? 0.44 falls between 0 and 1. Because that's a Z.
I thought we were talking about.
Oh, yeah, no, yes, that. So this is one standard deviation away, right? So if I wrote these in terms of the number, this is 0 more than the mean. How much is this more than the mean? I'm a little bit less than halfway there. And that's the way I would expect more of you to think about it than the way I just did it. But either way, you're still getting that thing.
Well, then what do you have to do the other way, because like, technically, if you interpret it, that could be 0.2 as well.
Because I said 0.44 is less than halfway, and then you have to know that part of it. But that would, even if you got there, you would at least eliminate down to 2 answers. I'm probably gonna do maybe one more. Yeah, let's do one more. All right, so histograms below represent the distribution on 5 different data sets, each containing 28 integers from 1 through 7 inclusive. I am going to talk outside of this problem because I would imagine you would see something like this, and I want you to understand what the problem is saying just right there so that you at least feel okay about that part and aren't distracted by that. What do you think the from 1 to 7 inclusive mean? Look at your graphs.
Each one of those columns corresponds with a number of 1 through 7.
So this column is 1, this column is 2, 3, 4, 5, 6, 7. And that works for all of these. Now, you don't need that to do this problem, but I want to explain to you what they're talking about because you'll probably see this and I don't want you to be distracted by it. And sometimes it can actually help you do the problem. This part is actually telling us our what?
N.
Our n. If you drew these out proportionally, so this is 1, so there's 1, 1, there's 2 2s, 3 3s, 4 4s, so forth. Here I could do this, and if I tried to break it down proportionally, so of this bar, there's 1, 2, 3, 4, 5. This bar, there's 5. So these bars, there's 5. These bars, there's 3. This one, there's 2. If you added up all those numbers, you're going to get 28. So sometimes that doesn't help you solve, or that doesn't like deter from this problem or benefit this problem. But sometimes being able to think about it that way can actually help you. Like if you're at the end of the AP exam and you're looking at this problem going, I have no clue, but I have extra time. You could sit here and type in your calculator 1 1 1 1 1 2 2 2 2 2 3 3 3 4 4 and so forth, and then find the standard deviation of it, and use that and get your answer. Y'all see what I'm saying? And just plug in the numbers for each data set, and because it all it wants to know is which one has the biggest standard deviation. Do I think that's your best bet while you're going through? No, that's a lot of time to find a problem in a way that you can probably do a different way. But if you have extra time and you run off to the side, I'm missing this point, I've got extra time, use that. So that's why I want you to understand what these mean. Now, let's think about the problem itself as just concept. So, standard deviation means what? What is the definition of standard deviation? Average distance from the mean. So, if there is a lot of pull or a lot of weight at the mean, what kind of standard deviation is that?
Right.
Low. If there is a lot of pull away from the mean, what kind of standard deviation is that? Higher. These two, here's my middle. My mean's going to get pulled that way a little bit towards the higher numbers. My mean would be somewhere here. So this is probably the farthest away. It doesn't have much pull. Most of my weight is pretty close. This is going to be about the same thing just because that's tweaked would maybe pull it this way a little bit more than that one. Still not that big of a difference. Where is most of my weight or pull in that problem? So that has a weight of 0 being most of your pull there. Here, Which is gonna be higher, this C or E, right? Because here, I have a lot of weight that's 0, and not a lot of weight that's -3 and +3. Here, I have less weight that's 0 and a little bit more weight that's +3 and -3 than that one. So this one is more than that one. But here, how many do I have that are 0 relatively? Few. How many do I have that are my highest number away? So being able to look at it really quick, this, for some people, this is a 10-second answer. To me, I have to think through this one a little bit more. To some people, you'd have to end up going back and doing it the way I explained it the first time, which is the way I used to always think about it too.
Which way, or what's the right about that way for this?
Something about the more, I want to write the way of the pool. More pool at the center, lower standard deviation. More pool far from center. The higher standard deviation. But the reason I wanted to explain this 28 1 through 7 thing is you're going to get to some problems where, like this one, like the typing in the numbers thing, it might be something like you can actually go through and calculate the mean or the median, which could help you do the problem in a completely different way than they would expect you to do it, but could get you out of a problem that you got stuck on.